In this portion of the video, we are going to look at what it means for a radical expression to be in simplest form. There are three rules that we follow to make sure that a radical is simplified. The first one, there are no perfect square factors other than 1 in the radicand. So what that means is all of these numbers up here in this chart cannot be underneath the radical. If they are there, you must remove them. The second rule, there are no fractions in the radicand. So there cannot be anything underneath the radicand. That's a fraction. We must fix that. And the third one, no radicals appear in the denominator of a fraction. So it would be something like this. This is considered unsimplified. But for today, we are only going to look at this first rule. And the first rule states, there are no perfect square factors other than 1 in the radicand. Now, how we fix this rule is this product property. This property states that the square root of a product equals the product of the square roots of the factors. Now, it starts out the square root of a number. Well, every number has factors. If we can break the number down into its factors and remove any of those perfect squares, then we can go ahead and simplify it. Now, a and b must be greater than 0, so that's telling us again negatives cannot happen underneath. And I like to think of this property as if the number is put together, you can break a number apart, or if a number is broken apart, you can put it back together. But for right now, we're just going to stick with the simple. We're going to try to make sure there's no perfect square factors other than 1 in the radicand. Now, there's two methods to accomplish this. Method 1 is factor using perfect squares. To use this method, you must find the largest perfect square that divides evenly into the radicand. So here is the example, 24. I would list the factors of 24, 1 and 24, 2 and 12, 3 and 8, and 4 and 6. And then I would look for the perfect square factors. So as I look up here, the only one that I see is 4. That is the largest perfect square factor. So we use 4 and 6 to break it down. So just like the rule states, 24 can be broken up into 4 and 6, which then can be broken up into square root 4 times square root 6. We know the square root of 4 is 2, and we keep the square root of 6 underneath. Now, what's interesting about this is that you can check it. So when you use your calculator to do this, we have the square root of 24 as this decimal. You can check your answer to square root 6, and you will notice they are equivalent. So square root of 24 is considered unsimplified because it has a factor of 4, which is a perfect square underneath the radicand, or as the radicand. Now, method 2 is primarily what we are going to be using because this method, until you get the hang of it, you have a tendency not to see the largest perfect square factor. Method 2 is factor using a tree, so your prime factorization trees, and I like to call this the barn method. We pretend that the radical is a barn and that the factors of the numbers are animals. So here is the square root of 27. I take 27 and I break it down into its factors, its prime factors. So you can see here, 3 times 3 times 3 make up 27. Those are all prime numbers. So all of those numbers go underneath the barn. Now, remember from the beginning of the video, 3 squared and the square root will undo each other. So basically, a pair of these will come outside because that's really saying the square root of 9. So you take the partners out, leave it on the outside. This 3 stays underneath the barn because it does not have a partner. Now, this is what you need to remember for this method. To use this method, your factors, or animals, break up into pairs. Once paired, they leave the barn together. So these here are left as 3. If a factor has no partner, it must stay inside the barn. This one here stayed inside the barn. All of the numbers inside and outside of the barn are multiplied together in the end. So now, let's look at a few examples of where this happens. So we're going to go to box 1, and for the most part, I'm going to show you using method 2. So the first one we are going to do is going to be the square root of 48. So if I'm using method 2, I don't have to worry about listing any of the factors. I just start breaking it down. You can break it down any way you want to. I'm going to use 6 times 8. Then I'm going to break 6 down 2 times 3, and I'm going to break 8 down 2 times 4. 4 continues to break down at 2 times 2. Now, all of these here are my prime factorization numbers. So, partners leave the barn. So this set of 2's come out. This set of 2's come out. 3 does not have a partner. It stays in the barn. Now, I multiply these two together, and I get 4 square root 3. Once again, you can check this on the calculator, but these two are equivalent. I know it is simplified because 3 will not break down anymore. Now, like I said, when you get the hang of it, you will be able to do method 1. Method 1 would be realizing this. 16 times 3 is 48. 16 is the largest perfect square factor, so you could do this way. And then you could say square root of 16 times square root of 3, which is 4 square root 3. But this way you have to work a little bit. You would have to list all the factors of 48. So I find that this method is, in the long run, it's a little bit quicker than method 1. So now let's look at number 2. This one is 3 square root 27. So I'm going to break down 27, 9 times 3, and then I'm going to break down 9, 3 times 3. So this is the one up at the top, but this one has a number outside. So this number is already outside. This set of 3's will come out. This 3 will stay in. I multiply these together, and I get 9 square root 3. Example 3, negative square root 108. Now on this one, I have a negative outside. Remember, that is just the negative square root. It cannot happen inside, but it can happen outside. So I first break down 108. I'm going to use 9 times 12. 9 breaks down 3 times 3. 12 can break down 4 times 3. 4 breaks down more at 2 times 2. So here are all of my prime factors. This set will come out. This set will come out. 3 must stay in. And I get a 6 square root 3. I cannot forget about this negative. It comes down and makes it negative 6 square root 3. Now, the last one, question 4, negative 9 square root 100. Now this one you could either do method 1 if you know the square root of 10. So it would be negative 9 times the square root of 100, which is just 10. So this would be negative 90. Now if you do the other method, you would have negative 9 square root 100, break 100 down into 10 times 10. Now, you can keep breaking down 2 to 5 and 2 to 5, but as soon as you get a match, it can come out of the barn. It comes out as 10, and we still get negative 90. Now, that's what will happen if that number underneath the radical is a perfect square. So, once again, in this video, we are only looking at this first rule. There are no perfect square factors other than 1 in the radicand. That means break the number up and look for its perfect square factors and remove them. Now, try the problems on the next slide.